All right. I guess, yeah, if you drive under a bridge, sound goes quiet like that. This is SWASA Distance Education, MBF3C, grade 11 college prep math. I'm Pete, and I'm your teacher. So, welcome. We finished off units 1 and 2. We finished off unit 2 last week. So, today we're going to start unit 3. So, hopefully, you have the unit 3 package with you and available. If not, you'll have to get that from the DEC. Now, for this unit, you're going to need a plastic ruler. Okay, if you have any choice at all, try and get one that has a good edge on it, because I know that people like to kind of bang them against desks and stuff, and the edge goes all wobbly. Now, if you have the choice, if you get a 15 centimeter 6-inch ruler, that just makes things a little easier to draw diagrams. It's just a shorter ruler, but whatever you can get will be just fine. Now, one of the things you don't really need here, even though it's trigonometry and geometry, you really don't need a protractor. I don't think there's anything we do. No, there is nothing we do here that requires a protractor. It might be helpful if you want to, check your work or something, but really it's not something. All you really need is the plastic ruler, and then you'll be fine. Okay. You also need a scientific calculator. Whoops. Well, okay. It'd be good if I know how to spell scientific. Scientific. All right, scientific calculator. Okay, there we are. And that's the one, and now you'll see it. It's the one that has the sine, the cos, and the tan buttons on it. Okay, they'll be there in a row somewhere, and in fact, we're going to be using those buttons for this unit. But we'll take our time and go slow. I don't think that I don't want to assume too much. So, if you are really kind of up on your trigonometry, so I'll apologize because we're going to do a fair bit of review. And if it's been a while, or if you don't remember any of it, then you'll be fine. We'll just start from the very beginning. Okay. So with that in mind, instead of just going right into the lesson, I'm going to do a little bit of a review here. And let's see here. Just going to make a new page. So the first part of our trigonometry, which is a study of triangles, that's basically what trigonometry is. And triangles just show up everywhere. They show up in building quite a bit. They show up in geography kind of things. The other thing that trigonometry gives you is problem solving, because the types of problems we get to solve in this unit are a bit more complex than the ones we've been doing up till now. They're actually interesting problems with multiple steps, right? So we get to practice our 4-step problem solving model. So when we're talking about triangles, there's a type of triangle, a special type of triangle, and you'll know it because it has a little box in one corner, and this is called a right triangle. Okay, now it can be drawn that way with the box on the left or on the right. It doesn't matter. But the fact is, it's a right triangle because it has this little box that I'm showing you now in red. You'll have to assume that these lines are all straight. I drew a really wavy looking triangle. Okay, so this is called a right triangle. That right angle there guarantees you that it is a right triangle. And what it means is that this angle is 90 degrees. Now, triangles are usually measured in degrees, at least in high school they are. What we have to know is that there's 180 degrees in all of the angles inside a triangle, which means that if it's a right triangle, it's special because we already know one of the 3 angles. It means that we know that the other 2 angles can be we know that they sum to whatever's left over, which is 90 degrees. That's what's left over, right? But if we add up all the angles in a triangle, they come out to 180 degrees, which means that if we know 2 of them, then we can actually work out the 3rd one. What the cool thing is, what we're going to study initially with trigonometry is that we can figure out the ratio of the sides. We can actually, if we know the length of some of the sides, we can actually work out the angles as well. Okay, but let's look at a few more things. We're going to go A, B, C, and some people go clockwise, some people go counterclockwise. The angles in a triangle, and this is all triangles, we usually use big letters. Okay, we use big letters to designate the angle. So if I wanted to ask you, what's the measure of angle B? Well, you see it's a right angle, so you're going to say, well, it's 90 degrees. If I say, what's the measure of angle C? You'd be looking at this one up here at this top, right? And you don't know right now, but you will. You'll be able to work that out. Okay, so when we talk about angle A, B, or C, that's what we're talking about. Okay, or if we talk about capital A, B, or C, we know we're talking about an angle. Okay. Now, the other thing that we do is once we've labeled the angles with capital letters, and you can use any capital letters, A, B, C, and then if we had another triangle, it'd probably be D, E, F. The only letters that we avoid is like I and O, just because they look like they're easy to confuse, but some people actually use them. I'd probably rather not. And normally it's consecutive letters. I think in some parts of the text they get a little creative and try and spell out words. I don't do that, but it's, why not have some fun with it? Now, if we want to talk about a side that's opposite one of these angles, so if I have the angle B here, and this line that's between C and A, which I'm going to just kind of put a dot here, we can designate that. We don't need to come up with a name for it because it's going to be little b. If the angle opposite is big B, then the side opposite is little b. So let's take a look at angle C up here. Then the side opposite is little c, and the side angle A is little a. There you go, right? So that's a way of referring to a side. So I could talk now, I could say, all right, side A is 10 centimeters long. Well, then you'd know that that's 10 centimeters. Okay, well, you wouldn't know it the way I wrote it there, but anyway, you sort of squint and it says 10 centimeters. Now, some texts and some people, um, instead of let's say calling this angle, or sorry, side C here, they just take the ends, put them in alphabetical order, and call it side AB. Okay, so that does work, and you're allowed to do that. It's the way I do it is with the little letters. I think your text does that too, but there may be some places where just because of different editors, they've used this other notation. Okay, but it's perfectly valid. And if you learned that one where you just talk about the ends of the line, then that's perfectly fine. So in that other notation, for example, side B would actually be AC, right? You could call it CA too. It's just traditional to kind of put it in alphabetical order. Okay, so that's what we got about with the right angle triangle. There's just a couple more things that I'll talk about here for the right triangle. Okay, there's parts of the right triangle that you really need to be able to identify. First of all, the right triangle has the longest side, which is always opposite the right angle. And I put an arrow to show you, right? That little corner of the right angle symbol is the box, the square box, always points to the hypotenuse. Hypotenuse. And the hypotenuse is always the longest side. Longest side. It's always the longest side in the triangle. And very often we abbreviate it with the letter H. If we're not that we're designating that, but if we're just solving a triangle in general, you can call it the H. Now the other sides, the ones that actually touch the box over here, right? See, these two actually touch this angle, whereas the hypotenuse doesn't. This is a leg. It's called a leg, and this is called a leg. That's it. So every right triangle has a hypotenuse and two legs. Okay, now the legs can be different lengths. Okay, and depending on what we're trying to figure out, the legs actually get a designation of a particular side type. Okay, and we'll get into that. But the hypotenuse is always the hypotenuse; it never changes. Okay, with the what we call the legs will depend on what angles we're looking at. All right, I think I covered everything. Now, if you get a question and it has what appears to be a right triangle, but there isn't a square box around there, you need to ask, because if it looks like it's supposed to be a right triangle, but it doesn't have that box, somebody is either messed up or they actually don't want you to assume that it's a right triangle. Okay. Now, in Unit 3, we're going to look at other triangles. We're going to start with right triangles because they have some special properties. That right angle actually gives us a little boost. Okay, it gives us a little boost in working out problems related to right triangle. So whenever we can, we try to, if we got a right triangle, we're going to use some tools in our toolkit that we're going to look at here to work out different things about the triangle, the right triangle. Then later on in the unit, we're going to look at general triangles, just three-sided shapes. And there's actually a surprising amount of stuff we can work out about them too. It's just the formulas are a little harder, little longer. Maybe not harder, just a little different. Okay, so we'll probably actually, we're not gonna, we'll probably take our time going through this stuff anyway. All right, well, let's, now that we've gotten that introduction, let's take a look at the actual first page of Unit 3, and that's page 2. Okay, and we'll kind of get going here. I'm going to check to see if we have, okay. Okay. So the other thing that you may remember from trigonometry, you may remember this. I'm just going to write this down. SOHCAHTOA, SOHCAHTOA. This is called SOHCAHTOA, right? And so there's three parts to it. SOHCAHTOA. SOHCAHTOA. Now, what does it mean? It people have different ways to remember what it means. I think it might be maybe an ancient OG Cree word that means triangle, or I love triangles. Not really sure. Okay, but that's how I would remember it. Okay, SOHCAHTOA. I love triangles. And I'll show you how this will help you work out as we go through this, because we're going to learn about these different ratios, and the SOHCAHTOA can actually help you remember them. Okay. All right. So the first one is called the sine ratio. Okay. That's how the word said, sine, S-I-N-E, sine. And the way we use the sine ratio is to calculate an unknown side in a triangle, or can you calculate an unknown angle, right? So basically, if we have a couple of pieces of information about the triangle, we can work out every other piece of information. Okay. All right, here we go. So this is a right triangle, and we know it's a right triangle because it has that little box right there. Okay, if it didn't have a little box, we would not be able to assume that it's a right triangle. Okay, so I'm going to say right triangle. Okay, and what that means is it's a right angled triangle. Okay, so some people will say right angle triangle. Mathematicians will say right triangle. It's a type of triangle. Okay, obtuse, acute, isosceles, different types, equilateral, different types of triangles. Right triangle. Okay, acute was an angle. All right. So we see we have the hypotenuse, and we know the hypotenuse is there because we have the right angle. So whenever you get one of these diagrams, I suggest you start labeling it straight away. Okay, now here's the important part. If we're looking at a particular angle, let's say that we're looking at angle A right here. Okay, now angle A, we need to use the hypotenuse, and we need to use the side that's opposite angle A. Now be really careful here. Notice it's the side opposite angle A that I just um, traced over in red. It doesn't touch angle A. Okay, notice that the hypotenuse, if I put that in green, notice that the hypotenuse actually is part of angle A. And then this other side here, this other leg, is also part of angle A. The only side that doesn't touch angle A is the opposite, which we could abbreviate as O, right? Or OPP if you wanted. It doesn't really matter. Okay. So here's a cool thing, and this is just a sort of a mathematical law, is that the sine of angle A is equal to the length of the opposite divided by the length of the hypotenuse. It's just a ratio. Okay, so the sine of A is also just a ratio, but we actually have a cool way of working out what angle A is based on the sine of A. Okay. So if we know then what the hypotenuse is, and we know what the length of the opposite, then we're going to be able to work out how many degrees is in angle A. Okay. Now, just before we move on, and I'll show you how to do that, because right now you wouldn't be able to do it because we haven't quite covered all of the steps. But I want to make sure that it's real clear here, that if we were looking at angle B up here at the top, okay, the hypotenuse is the same because it's always the longest side, but the side that's opposite angle B here is different, right? This is not the opposite of angle B. This one over here is the opposite of angle B. Okay, so be real clear that the opposite is always relative to the angle you're looking at. It changes depending on what angle you're looking at, whereas the hypotenuse is always the same. Okay, it's always the same part of the triangle. Okay, we'll get some practice working with this. Now let's take a look at the next page. So what they're asking us to do here is find the value of x. Now, I have a big problem with this diagram. I have a huge problem with this diagram, and I'm going to explain it to you. This is page 3. Okay, there's other issues in this unit. Do watch the diagrams because there are some mistakes, so be on the lookout for them. All right, trigonometry specifically, and geometry in general, is all about measurements. We are measuring things, right? There's very few things in geometry and trigonometry that don't have measurements attached to them, right? So when they just give us this diagram and they give us a 12 with no units, it's sort of aggravating because it's not, you never have that, right? So it's always going to be something, 12 something. So let's call it 12 meters. Okay? So now we have units. We're working in meters. So it says find the value of x. Okay? Okay. So so there's our hypotenuse. This is angle A, and if we look at the side opposite angle A, OPP, okay, so there we go. I think we have everything we need to set up an equation. The sine ratio, it says that the sine of A equals opposite over hypotenuse, okay? And in this case, we can say that the sine of 43 degrees equals opposite, which in this case is the 12 meters, over the hypotenuse, which is our x. That's the one we don't know. Okay. All right. So how are we going to do this? Well, we can just use our powers of algebra, can't we? We can isolate x by itself. Okay, so here's the first step. I'm going to multiply both sides by x. So we have x times sine 43 degrees equals 12. The x's that we multiplied, here's how I did it. I multiplied both sides by x, right? But on this side, the x's cancel each other out, right? So we're left with what I wrote below. Now, if I want to get x by itself, we're going to say x equals 12 divided by the sine of 43 degrees, because we divide both sides by sine of 43. Okay, we're allowed to do that. Okay. Now, here's something kind of interesting. If we look at this first equation here, and we see it says sine 43 degrees equals 12 um, meters divided by x, you'll notice that all we do is we just swap those around, didn't we? I mean, effectively, that's what we did. Okay, so keep that in mind. If you're solving one of these and you have the unknown in the denominator, you just have to, as long as there's no additions and subtractions on the left-hand side, you just swap them. Because that's effectively what you're doing. You're multiplying by one, you're dividing by the other, and you're welcome to do that all in one step if you want. Or you can take a couple extra steps to show it all. It doesn't matter to me. These are routine things, but if you want to show your work just to make sure that you're on the right track, I'll be happy to look at that. Well, that's great. So what it's telling us right here is that x, the hypotenuse, the length of the hypotenuse in meters, is equal to 12 divided by the sine of 43 degrees. Okay. Now, here comes the time, and boy, the book just kind of has a if they have a lot to say about this, but honestly, you can figure this out at this point. The one thing we want to make sure, though, is that the sine of 43 degrees is that you have your calculator in the right mode. Okay, so angles are measured in degrees. Degrees, really, degree, um, degrees. What D-E-G-R-E-E-S. Anyway, they're measured in degrees. They're also measured in something called radians, which is abbreviated as rad, and gradians, which is abbreviated grads. Okay, so on a lot of calculators, there's going to be a button that says DRG. Okay, and then in your display somewhere, it'll say DG, RAD, and GRAD. Sometimes they combine some of those, and one of them will be lit up. Okay. So you got to make sure that your calculator is in the right mode. Now, in high school and in maybe when you first get to college, you'll be doing everything in degrees. There's a lot of good reasons first to measure things in degrees. We're familiar with it, 360 degrees in a circle, 180 degrees in a semicircle, 180 degrees in the angles of a triangle, and that's what we learn. But if once you get into your college programming a little bit, they might show you some of these other modes here. That radians is a very common way of measuring angles. It's just a different way. It's like imperial and metric. Okay. So make sure your calculator is in degrees mode. So if you can't find a button DRG on there, you can send me the make and model of your calculator, or better yet, take a picture of it, send it to me, and I can tell you what buttons to press to make sure you're in degrees mode. But here's the test. If we type 43 and then press the sine button, okay? So sine 43, okay? You can just try it. What it should say, if you do sine of 43 degrees, notice that I've been very careful to show that it's in degrees. It should be 0.681998, something else, and then a bunch of other numbers. But it should be 0.681. If it doesn't say that, you're not in degrees mode. Okay? Now, there's a few others, just so you can practice. Try sine of 45 degrees and the sine of 60 degrees. Once you're in degrees mode, you shouldn't have to change it. But if you start getting strange answers when you're doing your trigonometry, maybe someone was playing with your calculator and changed it. So just double check that. So anyway, the sine of 45 degrees is 0.707107 or so. I rounded it off. But basically, it's going to say this, 0.707. And then the sine of 60 degrees is kind of interesting. The sine of 60 degrees is 0.866025. And again, there's a bunch of other numbers. Okay? So there you go. So you just press that button and try that. Try sine 45, try sine 60. Make sure you're getting all these numbers. Then you know you're in degrees mode. If not, look for a button that says DRG. Push it once. Try a couple of them. And push it. Might push it a couple more times until you start getting these numbers. Okay. Now, depending on when you learned all this stuff, you might have, when I was in school, you might have be asking me, but what about trig tables? What about the tables in the back of the book where we look it up? Well, that's the thing. We don't do that anymore. That's why math textbooks have gotten a little thinner than they used to be. They used to be like dictionaries, right? Now they're a little thinner because you don't have to have all that stuff in the back of the book. We just use a calculator. Now, if you have a smartphone, if you have an iPhone or other smartphone, you know that it has a built-in calculator in it, right? Well, the cool thing about it is that most of them, if you turn it sideways, so it's in landscape mode, normally it turns into a scientific calculator. You got to hold it for a second, right? So when you first start your calculator and you're holding it there, it just looks like a four-function calculator, right? But if you turn it sideways and wait for a second, usually it just suddenly turns into this scientific calculating beast where it has sine and it has everything else, okay? So if you have one of those, you can use that. It'll help you out. Okay. All right. Well, so that was my little aside here, which means that now we have to calculate this. We know now that the sine of 43 degrees is this number here. Now, what I suggest you do, if you're going to write down your results, write down, 6 decimal places and round it off. But leave it in your calculator and try not to have to re-enter these signs and other values into your calculator. So in this case, you find the sine of 43 degrees, and then you need to divide that into 12. There's a couple ways to do that. You can store it in the memory. You can divide this number by 12 and then find the reciprocal. Right? You can find the reciprocal of sine 43 and then multiply it by 12. There's all sorts of ways to do it. But anyway, the bottom line is that we have x equals 12 over, and it's going to be 0.681998, and then, or you could just say 12 divided by 43 sine, and you should get 17 point. Now, we're going to just round it to one decimal place. Normally, you'd round it to as many decimal places as your least accurate number. The problem with that is that in this diagram, the least accurate number has no decimal places. That's not really. So one decimal place is a good compromise. Now, what I wrote there is okay, but it's not correct. It's not correct because remember that trigonometry is all about measuring things. There's very, very few answers you're going to get in this unit that don't have a measurement attached. There's a couple of them, and I'll point them out, but everything else is going to have a measurement attached. So always keep that in mind. The only things that don't have measurements are the actual trig ratios themselves, and we'll talk about that. Okay, everything else, lengths, angles, they all have measurements. So the answer then is 17.6 meters. So now you're going to say, all right, well, that's 17.6 meters. Every time you get some new information, get in the habit of putting it on your diagram. Get in the habit of drawing a diagram. Write down what you know. Write down any assumptions that you make, preferably in a different color or somehow make it distinct, and then add any new information you calculate. Again, try to make it different from what's already there. So you know when you're looking back at it what you started with and what assumptions you made and what things that you calculated. Okay, it helps you if there's a mistake or if something just didn't quite work out right. It helps you go back. All right, but get in the habit of drawing a diagram for everything in this unit. Okay, that's probably, I would say, uh, once you get the diagram, for the most part, everything else, especially in the first couple of lessons, it should be pretty straightforward. But getting that diagram sometimes is tricky. All right, well, let's take a look at the support questions, and those are on page, was it 4? Page 4. So we're just going to step back a little bit, and we're going to just identify the parts of the triangle. Now notice they're trying to trick you a little bit here. That's fine. It's the right angle, but over here they flip the triangle upside down. That doesn't matter. We know, right? That's the hypotenuse. That's the hypotenuse. All right. Well, let's take a look at angle at A. They want opposite angle E. Now that's the way you read that. There's a little angle symbol in front of the E. Okay. So it's this opposite angle E. Now they don't really have to say the little angle sign. They could say angle E, but you know, it's just a little mathematical shorthand. Now remember that the side opposite, right? It's either going to be little e because angle E is big E, or it's going to be FG. Now the answer that I'd take either answer, but the one that I slightly prefer is the little e. It makes things a little easier um, to follow, I think. Anyway, okay, great. Now over here they want to know for B, they want to know the hypotenuse. Well, we know the hypotenuse. We have an arrow already pointing to it. This is the hypotenuse here. So what's it going to be called? Well, it could be little x, right? Or it could be YZ. Okay, either way, doesn't matter. Okay, again, I slightly prefer the lowercase. It just because when you're dealing with very complicated diagrams, you just get a tremendous number of letters all strung together, and having each side have a single letter is kind of handy. Okay. So for question 2, calculate the sine of A and the sine of B in each triangle. Oh, this is really interesting. Okay, make sure you can do this. Okay, this is really, really important. I can't tell you how many times I get students send in an assignment, and if they've got these mixed up, it makes it a little bit tricky to mark the rest of it, because you know if you can't sort out the sign, yeah, you need some more practice, right? So in that sense, if you're not real sure, you might want to send me just the key question, the first key question of this unit, rather than waiting and sending the whole thing. And the other thing you can do is just informally send me part of it. Just write a little note, right? Just because you send it to me doesn't mean it's some big formal thing. Write a little note on it and say, hey, this is the first 2 questions. Can you look these over? I'll be happy to do that. All right, so sine A. So remember now, this is going to be our hypotenuse. Always identify the hypotenuse. Okay, so here it's the A, which means that the side opposite A is this one, this little a right here. Okay, and this is sine of A equals, all right, it's the opposite, right? Remember, it's sine equals opposite over hypotenuse, or SOH. Remember SOHCAHTOA, SOH? That's the first syllable of SOHCAHTOA. So the sine of A then is going to be the opposite, which is 3.7 centimeters. I'm just going to erase that and it's getting a little fuzzy there. Okay, let's see. 3 point, okay, try that one more time. I can do this. I'm gonna switch to blue anyway. So sine A equals 3.7 centimeters divided by 4 centimeters. Now, all we want is the sine of A. This is the one time where you're going to have no units. And it's just a ratio. And the reason you have no units is because the centimeters cancel each other out. Okay, so the sine of A is going to be 3.7 divided by 4. Okay, 0.925. And that's it. That's the sine of A. Okay. Now, for the sine of B, we got to be careful here because the hypotenuse stays the same, but the sine of B, this is going to be the opposite right there. As far as B is concerned, that's the opposite. So the sine of B is going to be equal to 1.5 centimeters divided by 4 centimeters. So you see the hypotenuse stays the same, but the side that we consider opposite, it's relative to the angle that we're looking at. Okay, so that's really important. So 1.5 divided by 4 gives us 0.375. That's the ratio. Now, if we actually wanted to know the angle B, we could just, there is a way to figure it out. You're going to learn it, but they don't ask us what the angle is. They just want to see, they just want to know the ratio. Okay. In the old days, back when some of us were in school, you'd be taking that 0.375 and looking it up in the back of your textbook and finding out what the angle was. Now, we just press a button on our calculator. Okay. Now, this question 3 is, again, that's a useful one to do. Remember, the answers are at the back. So if you want to make sure that you understand how to calculate these things, um, it's good to go through this one. 3, 5, 7, 6. 6 decimal places is pretty good. I get 0.573576. The sine is 71. Okay. 0.945 519. So I rounded it to 6 decimal places. The sine of 55, 0.819152. So this is just to make sure that you have your calculator sorted out. 152. Yeah, 152. And sine of 90 degrees is, sine of 90 degrees is 1. Oh, interesting. Okay, I wonder if that's why right triangles are so special. Okay, it actually is. Okay. All right, so now over here, question 4, calculate the value of x. Just watching the time here. So what I'm going to do here is extend the page a little bit. I need a little bit more room here. Now, when you're doing these problems and for the key questions, you can try to cram in your answers on the sheet. They don't give you a lot of room, or you can just do it on a separate sheet. Now, you should probably do a diagram when there's diagram questions. Something like this where the diagram's given in the text. You could probably just do the calculations. Okay, it's up to you. Okay, but if it's a word problem or where they're describing a scenario or it's a complex situation, you should probably redraw the diagram. So question 4, it says calculate the value of x. So we're given this angle here. We know that this is the hypotenuse over here, which means that x is the opposite, right? So the sine of h equals, and that's capital H. Now this is the one problem where they're using capital H. They're using a different letter for the side, which is, by the way, you're allowed to do that. You don't have to follow the convention of using the small letter on the other side. Normally we do, but in this case it's the unknown, right? So let me just back up a little bit from that the way I started, because that capital H, which is the designation for the angle, they've gone HIJ. I call the hypotenuse H, so let's call it HYP. There we go. All right, so the sine, let's just jump right in. The sine of 37, really, seriously. All right, sine of 37 degrees equals opposite, which is x, over the hypotenuse, which is 3.7 centimeters. So we know that our measurements are going to be in centimeters. Well, this one, I hope you find this one fairly straightforward. We're basically just going to multiply both sides by 3.7. So 3.7 times sine 37 degrees. I just put them both in brackets just to be clear what's what. Okay, you don't have to. Um, and that's the thing about using brackets in math. It's really just a style thing to make your intent really, really clear. Okay, so there we go. So we're just going to do 37 times the sine, 33.7 times the sine of 37 degrees. 3.7 times sine of 37 degrees. Now, depending on your calculator, you might have to enter the 37 first and then press the sine button. So I get we'll call it 2.2 centimeters. Okay, so there you go. So then I would go up and I would say, all right, well, that's 2.2 centimeters. Okay. Now, the one thing, you look at your diagram, you want to make sure that it makes sense, but keep in mind that these diagrams may not be drawn to scale, right? So you could have a very large value for x that just doesn't seem like it would fit there. But the one thing you can be sure of is that your x will never be bigger than 3.7 centimeters because the hypotenuse is always the longest side in the triangle, right? So with that in mind, if you got 300 centimeters for x, then you would know that there's something kind of gone a little fishy there. Okay. All right, well, that's how you do these. Let's take a look at the other one then. This is triangle EFG for B, and we're supposed to find x, and we have the 23. That's our hypotenuse. So x is our opposite, so the sine of 23 degrees is the opposite, which is x over 18 centimeters. Okay, and again, this is just going to be 18 sine 23 degrees equals x. We just multiply both sides by 18. Now notice I didn't put the brackets around it this time. Um, some people do that and they'll do it this way and it's fine. Okay. So sine 23 and then times 18. That's another way to do it. I got 7.0 equals x. Okay, so 7.0. I meant to say just 0 there. I meant to draw a slash through it. Okay, and the reason I need to put that 0 there is that I do want to show that it's to one decimal place, but I don't want to show any more than one decimal place. As a matter of fact, really, by rights, the diagram has everything to whole units, 18 and 23. So strictly speaking, we would really have to round that to 7, but one decimal place is a good compromise. You don't want to have any more decimal places in your final answer than the lowest one on your original data, because basically it's false advertising. You're saying you're going to give them 6 decimal places, and you're saying this is accurate to 6 decimal places when you didn't start with 6 decimal places. Okay. All right. So, well, let's see. We're getting ready to kind of wrap up this class. We're going to keep doing this tomorrow for sure, and we'll probably go a little faster. Now, if you're reading ahead, I'm just going to point something out, and I'll point it out when we get there. At least one of these diagrams is wrong. I think it's the one about tangent ratio. Yeah, there you go. So on page 12, when they're talking about the tangent ratio, that diagram is wrong. Just in case you're reading ahead. Okay, if you read the text, it'll explain what it is. Okay, now, for these examples, we can just take a look real quick here on page 5. It shows how to find the missing angle of a right triangle. So far we've been using the sine ratio to find a missing side, right? And we can find a missing hypotenuse or the missing opposite, no problem, as long as we have that angle, right? Now, but we can also just find the angle as well, and that's where we find out how to convert that ratio into an actual number. Okay, so basically angle A, so they want angle A, right? And so we're going to say that the sine of A is equal to opposite, which is 18 meters. That's 18 meters divided by 23 meters. And then the sine of A equals, um, so it's 18 divided by 23. And notice that the units will cancel each other out. So we're just left with a ratio, which is 0.782. 609, just to kind of round things off. Now, the way that we convert this to an angle is we find the inverse sine. Inverse sine, which is designated as sine to the negative 1. Okay, that's how it's shown on your calculator. So we can say angle A is equal to sine to the negative 1 of this number, which means that you just have to find the button on your calculator that says inverse sine. I'll give you a little hint. 99% of the time, maybe even 100% of the time, sine to the negative 1 is the shifted function or the second function of your sine button. So if you look at your sine button on your calculator, chances are written in some color above the sine button, maybe blue, maybe yellow, maybe white, it'll say sine to the negative 1. So the way you access that is you have the number you want to find that sine to the negative 1 of in your display, then you press that colored button that corresponds to the color of the sine of the negative 1. If it's white, you press the white button. If it's yellow, you press the yellow button. And then you press the sine button. When in fact you're doing sine of the negative 1, you're doing the inverse sine. The inverse sine says, I have a ratio, tell me what the angle is. Whereas the sine, when you press that sine button, you're saying, here's an angle, tell me what the ratio is. Right? So, right, so let's press that on this last thing that we just calculated, and what I get is 51.5, and this has units. It's going to be degrees. Okay. Now, yeah, the book they actually did the right thing. They rounded it up to the nearest whole units. Yeah, I guess we could do that. 52 degrees. I used wavy equal sign. What that means is you're telling your reader, I have rounded things off, and this says approximately equal. Okay, and that should only show up in your very last line of your problem. Okay, it shouldn't show up anywhere else in the problem. I want to be as accurate as possible. Oh, look at that. They even, okay. So that's what they did. Okay. Now, if you shorten things down, round things, it could affect your final answer a little bit, but 3 decimal places is okay. I always prefer 6 decimal places whenever possible. Just a preference. Okay, and I think what it really matters is, if you're going to be doing some sort of like construction, if you're going to be doing like medicine or something like that, you want to have as much precision as possible. That's my thinking about it. That's why we keep 6 decimal places. Okay. Back many years ago when we were in school and we didn't have calculators, we did everything in 3 decimal places just because otherwise it would take us forever to do our calculations. Okay, that's why. All right, well, let's take a look at the next thing here. So now for support question 5, you're going to have a chance now to practice your inverse sine and practice calculating inverse sine. Okay, and then for question 6, you get to calculate the sine of a ratio. Now notice that these answers will be something in degrees, whereas these answers whereas these answers here to sine of E, that's just a ratio. It's just a number. So there's no units. for question 6. Okay. All right, and so you can try that. What we'll do is we'll come back tomorrow and we'll finish this off, and then we're going to look at there's 2 other trig ratios. We spent a lot of time looking at the sine ratio, but what you'll see is that the 2 other ratios, the cos and the tan, they work exactly the same way. They just operate on different sides of the triangle. So you'll have a real nice a full-fledged toolkit so that if you have 2 sides, you can always find the angles, and if you have an angle in a side, right, or a couple of angles, you can find the rest of it, right? So it works out quite nicely to have all 3 of those available. All right, well, let's wrap this up